All right, guys, so I'm going to go ahead and talk through these symbolic notation problems, and where it tells you that this form right here represents this expression. And so what you're going to need to do is evaluate each of these Roman numerals. And in any Roman numeral type of problem, when they have a list and you choose from that list, what you're going to do is you're looking to find counterexamples. Is it an example or counterexample? Or the other way to think of it, is that statement true, or can you find a case where it's false? So in each of these, if we test each of these statements by plugging the symbols into this expression. So x circle y can be represented everywhere there's an a, we replace it with an x, and everywhere there's a b, we replace it with a y. That's what the function represents. So if we look at Roman numeral 1 here, we take xy plus x plus y, again just substituting x is in for a and y is in for b. And we want to see, is this equal to when we replace y for a and x for b? So is that the same as yx plus y plus x? And so when we look at these here, we're looking at xy plus x plus y, is it equal to, and if we move these factors around, that's fine. And if we move these terms around, that's fine as well. So do we get the exact same thing here? Yeah. So you know that that statement is true. So right away, right now, you can eliminate what options? You can eliminate B and C. So even right now, if you can just do that much, it's in your best interest to go ahead and guess. You have a 1 in 3 chance of being right. The penalty, which is 0.3% or 3.3 for the probability, you have a penalty of 0.25, so that the chance that you guess right actually outweighs the penalty. So if you didn't answer A, D, or E, go ahead and, again, just take a second here and see if you can guess the correct answer from this step, which means you have, again, a 1 in 3 chance of guessing it right. All right, I'm going to go ahead and test Roman numeral 2. The same thing, but this time my a's are going to be replaced by the binomial x minus 1, and my b's are going to be replaced by x plus 1. So I get x minus 1 times x plus 1 plus x minus 1 plus x plus 1. So there's my left side, or this first expression here, and I'm going to see, is that equal to, in the right side, I'm going to replace a and b with x, and then I'm going to subtract 1 from that whole thing. So that gives me x times x plus x plus x, and then the minus 1 after it. And so this is just directly substituting in the form for that symbolic notation. Now I need to simplify each of these. So I have the sum and difference of terms down here. That expands into x squared minus 1, the difference of their squares. And then the plus x minus 1 plus x plus 1. And then here I can go ahead and multiply my x's. I'm going to go ahead and combine my x terms. And so when I simplify completely here, this 1 and this negative 1 cancel. I get x squared plus 2x minus 1. Is that equal to x squared plus 2x minus 1? Yeah, so I know that number 2 is also true. So based on that, which one can I eliminate? A. Okay, so now you have a 50-50 chance of guessing right if you can get this far. Hopefully if you can get this far, you've understood how the process works, and you can do the same thing for this last problem, or the last Roman numeral. Hey, in this last one, when you plug these in, we're going to plug x in everywhere there's an a, and we're going to plug the binomial y plus z everywhere there's a b. So let's evaluate that. We get x times y plus z plus x plus y plus z. And we want to see, is that equal to, here we plug in an x for a and a y for b. So xy plus x plus y. And we're then going to add that to plugging in x for a and z for b. So xz plus x plus z. Okay, so the last thing we want to do here is expand all of this and combine our like terms and see what we get. So if we distribute the x through, xy plus xz plus x plus y plus z, and we want to see is that equal to here xy plus here I can combine my two x's plus y plus xz plus z. So when I look at these two sides and compare them, I have an xy and an xy. I have a plus xz and a plus xz. I have a plus y plus z plus z. But now I have a plus x versus a 2x. So is this going to be a true statement? No. So at this point now, I can identify my answer as choice D. But you can see this is a time-consuming problem. It earns its difficulty level of 5. But you can still approach it with a systematically plugging in the variables for the correct function.